Hello, am I audible?
Good evening, sir. Yes, sir.
Yeah, good evening to all of you. So this session is about doubt clearing session, which so far you have done to week 4, I think. Yeah, all the topics of week 4 has been covered, right? So if any one of you have doubt related to any concept or anything up to week 4, so you can raise your hand and we'll discuss the things.
Hello.
Hello. Yeah, hello. So who has doubt? You can raise your hand, and we can discuss the things in any topic you have doubt. So you can ask. Hello.
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 Please start the session, sir.
Hello. Yeah. Yes. Yeah. So I'm saying, who has doubt related to any concepts of week 1 to week 4? So you can raise your hand, and we'll discuss the things, right? So this is basically doubt session. Okay. Uh, so far, all the topics of week 4 has been covered, right? Week 1 to up to week 4. So if you have any doubt, so you can, yeah. So Bhavya has, yes, Bhavya, what is your doubt?
So can you go through once with all formulas of the median mode with numerical and categorical data because and some of there are have doubt in the questions I have.
In which question you had doubt?
So please wait for a second.
Yeah. Okay. Please tell. And Irsad, can you mute yourself? There is some background disturbance from your side.
Okay, sir.
Okay. Anybody else have any doubt?
Sir,
So
can you tell what is the difference between population and sample?
population and sample.
Yes,
Okay. So what do you understand? I mean, what's your thinking on this? I just want to know your approach. What is the meaning of population and sample? Hello. So yeah, let me see.
Here in sir practice assignment 1.1 non-graded of week 1.
Practice assignment 1.1. Okay. Is my screen visible to all of you?
Yes sir.
yes, sir.
Which question?
Sir, fourth question.
Okay. So it might be like different question because
Yes
which
sir,
fourth
this
question?
is No, sir, this is not four questions. Sir, 1.1.
Yeah, it's a 1.1. Actually, thing is that after each refresh, you will get the different set of questions. So I'm going
Sir,
to
can I?
refresh. Just let me know which question is there.
Yes,
Okay.
sir, this one. Fifth
A mobile
question.
manufacturing company received feedback from customers complaining
Yes, sir.
mobiles bought were defective. Okay. To confirm this, the company randomly selected 100 mobile phones from the total mobile phones. Okay. And
Yes.
checked for the defectiveness of the mobile. Which of the following options is oblique or correct? So, can you tell me which options would be correct according to you?
Sir, here, according to me, it is a company defective. So, sir, it will be descriptive, not.
It
Sir,
will be
randomly selected 100 mobiles is a
phone.
population.
Yeah. Is a population or is
Third
sample?
and fifth option are correct.
Population.
No, no. See, you have population, your total mobile, right?
Yes,
And
sir.
out of those total mobile in the company, you are selecting 100 mobile. So is this sample or is this population? The 100 mobile phone.
Sample.
It's a sample, right? Because I'm selecting, I'm going to do some analysis and all things on the based of that sample. Because
Okay.
sample is what? Is nothing but a subset of the population, correct?
Yes, sir.
So third option is the correct. And which another option
Sir, with all the mobiles manufactured in a company is population.
is the population, correct? Right?
Yes.
And
Sir, but here inferential and descriptive statistics here I am confusing at this point because descriptive is describing or summarizing,
yeah, correct.
whereas in but here is not
Mhm.
descriptive as not inferential.
No, no, no. See, Bhavya, question is asking about, see, suppose company randomly selected 100 mobile phones from the total mobile phones. Okay. So you understood what
Yes,
is the
sir.
sample and what is the population. So far it is clear.
Yes,
Okay.
yes,
Next is
sir.
and checked for the defectiveness of the mobile. So question is asking about which I mean whether inferential statistics can be performed on the data, descriptive statistics can be done using this data or not. This is the question, right? So suppose
Okay.
I have chosen 100 mobile, right? I have
Yes,
selected 100 mobile, correct? Suppose this is the uh, whole population, I mean all mobiles in that
yes, sir.
company, and I choose a
Yes,
100 mobile. Okay, so this
100
is the my
mobiles.
sample, and this is the my population.
Okay.
So question is asking about uh,
Yes, sir.
that first option is saying inferential statistics can be done using this data. I have data. Which data is? I have this 100 mobile phones which I have selected. Okay,
Sample.
so
Yes,
based
sir.
on this sample, I can perform inferential statistics or not?
Yes, sir.
I can perform. Say,
Yes, sir.
suppose I select I in these selected 100 mobile phones, I found like some numbers. Let's say I found 50, uh, 50. No, not 50. Let's say 30 phones are defective. Okay, I checked for
Yes, sir.
defectiveness. Then I made conclusion on the behalf of this sample data for this whole population data. So it will be inferential.
Sir, then it will be inferential because at last we are making
Yeah,
conclusion.
when we will make the conclusions. So be careful
Conclusion.
what option is saying. Option saying inferential statistics can be done, not it's your like it is I mean happening here,
So,
it
but
is asking about
then both can be done.
yeah, the descriptive statistics can be done also here.
Okay, sir.
Okay, so
Okay,
descriptive
sir.
statistics is what, it's a nothing but to summarize the data set, right? So I
Data
have
sets.
100 mobile data set and data set of 100 mobile. So I can summarize the data set. I can say, yeah, maximum number phones are not defective, minimum number phones are defective. I can plot some chart and all things, right? I mean, meaning is that I can describe my data set, right?
Okay,
So
sir.
that's why these two options will also be correct. It is clear?
Yes, sir. Sir,
Any?
then
Hmm?
second option, then second I have doubt in principles.
Sorry, you are, I mean, I was not able to listen. Can you repeat?
Sir, sir, I have doubt in area of principles,
Area of principal.
statistics.
Okay, so it's about. Okay, is there any question related area of principal?
Okay.
Is there any question or should I give you concept?
So can you go through once for with concept?
See, for the concept, can you tell me, have you attended the revision sessions conducted
Yes,
by the
sir.
Ishan sir?
Yes, sir.
So, I mean, you got the idea or not for
Sir,
that?
I got the idea, but there some at point I am
Okay, so can you tell
not
me
still
that at which point you are getting stuck? So, thing is that,
and
see, you have
x-axis
a idea.
x-axis
So,
y
yeah, yeah, please.
at axis at x-axis and y-axis. If we are
Mm-hmm.
if we are starting with some much bigger amount like 100 or 200 as a
Mm-hmm.
starting point at x-axis, then what will become there? What will be placed? Sir was asked us to place a size.
See, I'm going to give you a quick idea. So, what
Yes,
you
sir.
think? So, see, area principle is nothing but it. See, thing is that I have data set. Okay, we may have any
Sir.
data set. Okay, so display of data must obey a fundamental rule which is called the area principle. So area principle means the area occupied by a part of the graph should correspond to the amount of the data. Okay,
Sir.
are you getting my point? It's saying
Yes,
area
sir. Yes.
occupied by a part of the graph should correspond to, see, should correspond to the amount of data it represents. Means suppose I have a pie chart. Okay, let's
Yes,
take
sir.
example of pie chart. So
Eye
in
chart.
this pie chart, suppose this there is any company and owner of that company is interested to know the sales percentages of four items. Okay, suppose in that company uh, they are manufacturing four items. So suppose this is 30%. Okay, and suppose
Sir.
this is 45%, and suppose this is 15%, and suppose this is 10%. So total is 100.
Yes, sir.
It's a 60. Yeah, total is 100%. So thing is
Yes,
that
sir.
is this correct or wrong? This pie chart.
It is correct. It is correct.
Why? Is this
No, sir. No, it is not correct because 30 is greater than as compared to 45.
and you can say for the 15 also,
Yeah, 15 is
it's
also
not
greater than.
representing the area occupied. That should correspond to the data it represents, right?
Yes,
15%
sir.
should be this one, 30%
Yes, sir.
is okay, and 45% should be this one, right? Kind of thing.
This was it. This one.
So here
Yes, sir.
your area principle is not followed, correct? In the case of this pie chart,
Yes, sir.
are you getting? So area
Yes, sir.
principle, sometimes we decorated the our bar chart,
Yes, sir. In like in colored chart or
color chart, and
3D,
you there is
third
example
3D
ma'am
charts,
taken by the ma'am
3D
that
photographs.
wine export from
Yeah.
the some four countries, right? So
Yes, yes.
but that, see, uh, by observing that graph, so we can get a quick idea, but that is not a correct one. Okay, so
Yes,
that's
sir.
the meaning of area principle, correct? This is for the
Yes, sir.
pie chart. Similarly, for the, you can go for the, if you go in this week 2 activities questions, there are a lot of questions related to area principle like this. See,
Yes, sir.
this is
Yeah, here.
not follow the area principle. Okay,
Yes, sir.
because this 38%, it's not that much amount which it's covers here, right? It should be
Yes, sir.
62%, and blue region should be 38%, correct? And
It
what
is
about this bar chart?
width of the bar chart.
Yeah, this is again, this is not follow the area principle, correct? So that is
Yes,
something,
sir.
it doesn't not you can say occupy the amount of the data which it should represent here, correct? Okay,
Okay, sir.
clear?
Yes, sir.
you explain this question?
Which one?
This
Complicated.
fourth one?
This question? Fourth one.
Yes.
So, I mean, what is the doubt here? I mean,
So we have given the baseline is missing, options are baseline, missing baseline,
mhm.
manipulated y-axis,
It is not a
and
misleading graph, both
I marked it as both missing baseline and yes.
okay. So, what is the meaning of manipulated y-axis? Do you know?
No, sir.
Fabi, I think you have not attended the sessions, right? I think all the concept has been covered there. Okay, so let me tell you. So here, I mean, my bar chart is not starting from the zero, correct?
Yeah.
Yes, sir. Not
That means
starting
it's
from
a missing
zero.
baseline.
Yes, sir.
Now, come to the
Yes, sir.
manipulated y-axis. Okay, so I'm going to present. So if you go in the resources from instructors, so there is a week 2 FAQ. Okay, let me download this thing. So you can prefer this one. So see, what is the meaning of manipulated y-axis? So it's nothing but, suppose I'm expanding or compressing the scale on the graph y-axis, right? See, by seeing this graph, I can get the idea, like, see, A and B is the two mobile shop, okay? And
Yes, sir.
this bar chart is showing the number of sales of smartphone in shop A and number of sales of smartphone in shop B, correct? So by seeing this first bar graph, we can get a quick idea, like there is a significant amount of sales in the company, I mean shop B.
Yes, sir.
It is clear so far?
Yes, sir.
Yes,
Now,
sir.
Till here.
come to the next. See, by seeing this here, we have some expanded the y-axis. See, if you see here, y-axis is 0, 10, 20, 30 up to 120. Okay, but there is no need of doing any manipulation up to 300. But if suppose I have done this manipulation on the y-axis, then this by observing the second graph, if you see, then it doesn't not looks like in the shop B there is a significant number of sales. It looks like approximate similar, right?
Yes, sir.
See, in the first, I can see, yeah, in the shop A there are 80 mobile phones has been sold. In shop B, 120. I mean, there is a significant number of mobile phones has been sold out, correct? But in the second graph, it looks like very less. Why? Because there is manipulation on the y-axis.
Yes,
Are you
sir.
getting?
Yes, sir.
And uh, one more thing on the manipulation of y-axis you can do. Suppose this is the y-axis. Suppose this is A, this is B. Okay. So suppose A is till here and B is till here. Okay. Suppose this is
Yes, sir.
0, this is 5, this is 30, this is 35, 40, 45, 50. So is this manipulative y-axis or not?
Yes, sir. Manipulated.
Why?
No, sir. It is not because it.
Anybody else? Is it manipulated or not?
Yes, sir, it is manipulated.
It's manipulated because initially it was 0 to 5, but there is sudden some manipulation has been done, and it starts from the 30, 30 and 35 onwards, correct? So this is the some manipulation which
Sir,
has
but
been
it
done
is
on the
taking.
y-axis. Okay,
Sir, but it
and
is taking
suppose
at middle of this place.
and suppose instead of this one, uh, we were at the activity. So I'm going to show you a graph. Okay, okay. So in this figure 2.4.6, is this manipulated y-axis or not?
No,
Why? It's again 0, 5, but
No, sir.
jump is 50.
sir. Because it is. Because here is marked.
Yeah, correct. Because the break, the jump is shown, like right. So initially it was 0 to 5. Then there is some manipulation. There is some break, and break has been shown on the axis, and then it starts from 50, 55. If the break is not shown, okay, then
Yes,
you
sir.
can consider as manipulated y-axis. And if and this one, suppose I have expanded the y-axis or compressed the y-axis, and that graph gives some less information, that graph is mislead to us, then this is the part of the manipulated y-axis in the case of bar chart. Is it clear for everyone? Is it clear for everyone?
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
So after Bhavya, do you have any doubt now?
Sir, in 3.3, non-graded assignment.
Practice assignment, right?
Yes, sir. 3.3, third week of third.
Okay, you are asking about activity 3.3.
Yes, sir.
Okay, in which question you have doubt?
Sixth question, sir.
Okay, what is your doubt?
Sir, the median of the data x1, x2, and x3 and xn is 45, and the median
Okay,
of the 3x1 plus 1,
1 3 x 2, I mean,
3x2.
I'm asking what is your doubt in this question?
Sir, I am not able to solve this.
Okay, so what was your approach? I mean, how did you start?
Sir, I started writing x1, x2, x3 till xn,
Mm-hmm.
and and l- and taking this x1 x2 as xx as x, whereas and 3x plus 1 3x plus 2, 3x2 plus 1 as
Mm-hmm.
is taking as y variables.
Okay.
Then I am taking then I am multiplying both the variables with x and y and dividing by 2 because we need to find median.
So how did you know this n is a even number? See, simple things. Anybody wants to tell this question? Anybody? So it will be no Anuja. Okay, see, you know there is just properties of related to mean, median, and mod and variance, standard deviation, and all things. So I suppose I have a data set. Okay, x1, x2, so on, xn. Okay, I have this data set. Suppose I am interested to add a constant c to all the observations, right? Then my new observation will be x1 plus c, x2 plus c, so on, xn plus c, correct? And suppose
Yes,
median
sir.
of this data set is, let's say I'm saying as md, let's say old median, I'm writing old median, and so what will be the median of this new data set, correct? So median of new data set is nothing but new median equal to old median plus that constant, that's all.
Yes, sir.
Okay, and suppose I'm going to multiply it by a constant c to all the observations. That means my new observation will be x1 times c, x2 times c, and so on up to xn times c. So what will be the my new median? I mean, new median means median of this new data set, what will be?
Old data set plus c
Into C.
old
Median
da-
into
into
old,
c
the
old median
into
into
c
c, that's all. Okay,
into c.
so Bhavya, in the question it is given that median of x1, x2, xn is 45. Okay. So it is asking about what is the
Yes, sir.
median of 3x1 plus 1 and so on 3xn plus 1, correct? So
Yes,
this is
sir.
your old median in the question is given to you. So when you will add a 1 to this one, so what will be the new median?
45 plus
2.
146 into 3.
Okay. So before adding 1, in if you see carefully, 3 has
we
been
have
multiplied,
got to
right?
multiply it.
So
Sir,
3 has been multiplied.
136.
So 3 into 45, then plus 1. That's all. So it will be 45 into 3. So you have to just find the
Sir,
answer.
136.
135 136.
That's all. So this is the something.
Okay, sir.
Clear?
So
Sir,
we need not to go
sir,
through all this.
Yeah. Yes, please.
sir, measures
Sir, we,
of dispersion,
Sir,
can you give
what
a
will
brief
be
explanation?
Yeah, one by one. One by one.
sir,
Sir,
just a second here. Sir, say at same
could you
point,
please just
10th question.
pardon the thing which you explained just once again, please pardon.
This whole things.
No, just the last part.
This one.
Yeah, how did we reach this 45 into 3 new median?
Okay, so in there is a question in the practice assignment is saying median of a data set x1, x2, xn is 45. It's given to us. It is asking about what is the median of 3x1 plus 1, 3x2 plus 1, and so on 3xn plus 1. Okay, so you remember the properties of the median. If I'm adding the constant, adding a constant to all the observations, then my new median will be old median plus c.
Right, sir. Right, sir.
Correct?
Correct.
If I want to multiplied by a constant to all the observations, then my new median will be old median into C.
Into
So
C.
far
Right.
it is clear.
Right,
So in
sir.
the
Right.
question, median of x1 plus x2 is given to us as 45. It is asking about what will the median of 3x1 plus 1, 3xn plus 1.
So
Okay,
3 into 45 plus 1.
plus 1. That's all.
Okay. Thank you, sir.
Clear?
Sir, I have a
Sir,
doubt.
I have a doubt.
In the
sir,
qualifier question,
Yeah, see, one by one. Please
measures
let
of
me finish
dispersion,
the
sir.
doubts of Bhavya. Bhavya, it is clear?
Sir,
Yeah, I will
10th
come
question of
one
the
by one.
same part.
Sorry?
10th question of the same part of 3.3 activity.
So 10th question is the same one.
Mode, he's asking the mode.
Okay, so what is the property of mode when you will add a constant
Waste.
to a
Uh, adding mode is equals to new mode is equals to old mode plus constant.
and when you multiplied by a constant, then what will be the mode?
Then for 2 into 45 plus 5.
That's all. So just try to think. Okay.
Okay, answer. So just a second. 4.6 question 3. 4.6
So after
question
this
3.
question, I will take the doubts of the rest of the people. Question number 6, sir. Okay. There is only 3 questions.
No, sir. Here's just a second. Yes, sir. 4.3 question number 6.
4.3.
Yes, sir.
There are only 4 questions.
Sir, 4.6 question number 3. 4.6, sorry. Covariance of covariance.
So what is the doubt in this?
Sir, here asked me to calculate sample covariance.
Okay.
So,
So what is the
and
formula of sample covariance?
xi minus x bar into yi bar
Okay.
divided by n minus 1.
That's all. Summation should be
Yes,
there, right?
yes, sir.
So
Summation
simple
summation of
things,
x.
you have x observations, you have y observations, just compute the mean, find the xi
Sir,
minus x bar, find the yi minus y bar,
sir, I
please
am
multiply.
finding the same, but answer is not coming that I need.
So there is some calculation mistake, so you can check. Okay, you have to just apply the
Sir,
formula.
can
No
you,
need.
sir, here n minus 1 will what will take? Just tell me that, and I will.
Minus 1.
And minus what will be taking n because number of objects is 4.
So n is the 4,
N is the
correct?
4. Okay.
Simple thing. N is what? N is the number of observation, right?
Okay, sir.
Sir,
Okay.
it is sample, right?
Yeah, it's a
4,
sample. So n is 4. So
4
in this,
minus 1.
if you will put 4 here, so it will be 3. That's all. Okay.
Okay, sir.
sir,
Sir, let me try
2.4
and
number
will come
5,
with
in
you.
which you explained the misleading graph, I just got disconnected due to internet issue. Could you please pardon what was said, why it is misleading?
Which one? 2.4.
2.4 number 5.
Okay. One second. 5. It's not misleading.
Sir, why this break between the bars? I mean,
Okay.
there's a middle line.
Yeah. So suppose. Okay. One second. You know this. This is the manipulated y-axis
Yes, sir.
because there is some jump, some manipulation is done on the y-axis, but it's not
Yeah,
shown.
there is no
Okay.
regularity. There is no
There is no
regularity.
regularity. But
Yes.
in this graph, things are very clear. Means at the 5 there is break and it's shown like break is there. That means it's not like there is some lack of information. They provide all the information at the 5. There is we are doing some break and all things, right? They are telling us. I mean, this bar chart is telling us kind of things. So
Oh,
misleading means they are not provide the whole information. Like, see, in this, I'm not showing the break, right? That means I'm going to mislead you,
right, right,
correct?
right.
So that is the mean. Okay.
Okay.
Sir, I have
Sir,
doubt in graded assignment too.
So one after Bhavya, yeah, I will
Sir,
go one by one. Okay.
sir,
So
measures of
yeah,
dispersion, brief explanation, sir.
yeah. If I will come to you, I'm going to one by one. Who has raised hand? So after Bhavya, Vidatri has raised hands. So yes, Vidatri, what is your doubt?
Sir, I have a doubt in practice assignment 2, question number 4.
Which practice assignment? 2.1 or 2.2?
Second, second, second week practice 2.1, sir.
2.1. Okay.
Yes, sir.
Question number 4. This is,
Wait.
it might possible question can be different.
No, sir.
For,
It is on relative frequency.
okay, okay. Let me refresh
Choose
once
the
because
correct
after each
option.
refresh, we'll get some difference. This one.
No, sir. Another one.
Okay, let me refresh. This question.
No, no, sir. Wait, sir. I will tell the question, sir. The option was choose the correct option. The option
Mm-hmm.
was relative frequency is always the same. For if the frequency is same, relative frequency is always same. Something like that it was. So I have doubt in that.
Okay, okay. 1 second. Let me refresh one more time so that can get the question. This, not this one. This one. Two data set having the same relative frequency.
Yes, sir. Yes, sir.
Okay. So in which option you have doubt?
First option. First
It is
option.
saying two data set having the same frequency distribution will always have the same relative frequency. So what the thing?
Sir, if the total is different, relative frequency will also change, no, sir.
Okay, let me come to you. Suppose I have data set 2, 3, 4, 2. Okay.
Okay, sir.
So what will be the relative frequency? This is 10. Relative
Yes,
frequency is 0.2, point 0.2, point
yes,
0.3, 0.4, 0.2.
yes, sir. Same
Correct?
relative frequency within the table, sir. But I am asking same
But
relative frequency between two different
1 second,
tables.
1 second, 1 second. So this is the, so okay. In the question it is saying two data set having the same frequency distribution will always have the same relative frequency. Okay. So this is the data
Okay.
set 1, correct?
Yes, sir.
Suppose there is another data set 2. It is saying which have same frequency distribution, correct? So it's obvious relative frequency again it will be same. Okay. Read the statement carefully. It is saying two data set having the same frequency distribution. This is data set 1, this is data set 2. So this frequency distribution of this data set is same as the frequency distribution of this data set. It's saying will always have the same relative frequency. So the same this relative frequency is the same as this one. Okay, are you getting? Hello, Vidatri, is it clear? It's not here.
Sir, I have doubts on
Hello.
percentages and
Hello.
Yeah,
quartiles.
with that three now it is clear.
Sorry, sorry, sir.
Okay,
I
okay,
got
nice. No
disconnected.
problem. No, no worries, no worries. So after Vidatri, Janab has doubt. Janab.
Sir,
Yeah, yes, please.
Good
sir,
evening, sir.
in
Yeah,
this
good evening.
only, if the relative frequency is same in two data set, but it
Hmm.
is not necessary that frequency distribution should be same, na, sir.
Yeah, it's not necessary, but thing is that what the statement is saying, I have two data sets with the same frequency distribution.
Yeah,
Will
that I
always have the,
understood, sir. The third
yeah,
option,
third
the
option. Yeah, two data set having the same relative frequency will always have the same. No, no, it's not possible.
yeah, that one.
Because suppose I have this data set, okay. Suppose another data set I have, let's say it's a 4, it's a 6, it's a 8. Okay, 1 second. Let me create a data set like that. Can be 4, 6. 1 second. Yeah, there is a one data set. 1 second. For, so it can be possible like two different data set. Okay, may have the same
Okay, sir.
relative frequency. Okay, just give me a
Okay, sir.
second. I'm going to think for the. So
Sir?
yeah, yes, please tell
Yeah,
me.
I have doubt on percentage and quartiles.
Okay,
Mainly, to be specific, on the graded assignment of week 3, on question number 3, 4, or anything like,
okay. Yeah, yeah. I will come to.
or
I will
4 and
come.
5, yeah, something. Yeah.
Okay, I will come to this. 1 second. So I will go one by one. Okay, so that's why I said just raise your hand. Okay, so suppose I have data set one, a data set one as 4, 1, and 5. Okay, and another data set two has 40, 10, and 50. Okay, so what will be the relative frequency for this data set? It will be total 10. It will be 0 0.4, 0 0.1, and 0.5. Correct?
Yes, sir.
And what will be the relative frequency for this second data set? Again 0 0.4, 0 0.1, 0.5. Correct? You know what is the
Yes,
relative frequency? Frequency divided by total number of observation, right? See,
yes, sir.
relative frequency for the 4, it's frequency divided by total. So total is 10. Here it will be 40 by 100, which again. So here we have two different data set, right? But we have relative
Same
frequency
relative.
same. So far, I mean, it's clear now.
Yes, sir.
Okay, nice. So I think Janav, Fateh, what
Yes,
is your
sir.
doubt?
Good evening, sir. It was
Yeah, good.
not me, it was someone
Oh,
else who was asking the question.
okay, yeah. Please go ahead.
Sir, is range more sensitive to outliers than mean?
Yeah,
Okay, sir.
okay.
And can
Because
I
see,
take
okay. Suppose I have data set 1, 2, 3, 4, and 5. Okay. What is the range of this data set?
5 minus 1, 4?
Correct.
Yes,
Suppose I
sir.
have data set. What will be the range of this data set?
3.
900 minus
3.
1, 8 and 99.
Yes, sir.
Correct. So
Yes,
it's
sir.
more sensitive to the outliers, right? Mean is also sensitive to outliers, but median is less than mean.
Okay, sir.
Okay, because you can compute the C. What is the mean of this data set? What will the average? It will be 5, 4, 9,
3,
12,
sir.
3, right? 15 by 5, so it's a 3. What will the mean of this data set?
It will be 15 plus 9, 15 divided by 6.
915 divided by 6. So what will be the mean? Sorry, mean. It will be 152.5. Okay.
Yes, sir.
So mean is also affected to the outliers. Suppose this is what will the median for this data set? 3.
3. Yes, sir.
What is the median of this data set? 3.5.
3 plus. Yes, sir.
So
3
it's
plus
the
50.
least affected, right?
Yes, sir.
Okay, it is now clear.
Yes, sir. Sir, can you take quiz 1, question number 81?
Yeah, I think. Can you tell me the question, because I don't. I mean, I need to search the set question set.
If 5 number summary of a data set is 5, 10, 15, 20, and 25. Later,
Can you
it
tell
was
me one
noted
second?
that 1,
5, 5,
10, 15, 20, and 25.
20, and 25. This is the 5 number summary of a data set. Okay.
Yes, sir. Later, it was noted that one observation 6 is wrongly noted as 5.
Okay.
Then choose the correct options.
Okay.
The
So
options are: the 5 summary may remain the same. The 5 number summary will definitely change. The minimum value of the data set will definitely change. Or the 5 number summary will always change whenever our observation is wrongly noted.
okay. So what should be the correct option according to you?
According to me, it should be yeah, the last option, but the correct option is option number 1.
May remain the same. Okay. Okay. You
Yes,
know
sir.
what is the 5 number summary? Minimum value of a data set?
Maximum,
Q1,
yes, sir. Q1,
Q2,
median, and Q3, and
maximum. Okay.
maximum. Yes, sir.
So you said one observation 6 is wrongly noted as 5. Okay.
Yes, sir.
So it is saying 5 number summary or data set should may remain same. What's the option? 5 number summary may remain same, right?
Yes,
Mm,
sir.
yes, sir.
That is the option. Okay. Suppose in my data set I have like this 5, 5. Okay. Then something else. Okay. And suppose
Yes.
one observation was again 5, for example, and one observation, suppose 6 is wrongly noted as 5, only one observation. Suppose this observation is was should be 6, but it is wrongly noted as 5, correct?
Okay, sir.
But minimum of the this data set, it may, I mean, it will be 5 or not.
Yes, sir.
Suppose in the data set you have two 5 and one 5 was wrongly noted as 6, then even though you have one more 5,
Yes, sir.
that means minimum of the data
Minimum
set
will be
will be
5 only.
okay. So that's why it's written it may remain same. It's not like it will remain same, it may remain same, it may not also. Okay, you can't say like it will definitely change. Okay,
Okay, sir.
clear?
So, sir,
Yes,
how
sir.
we will came to come to know that it will change or it will not change?
It's just a
Yes, sir.
simple things, Bhavya. Okay, you to, I mean, you can think like, okay, it's just a statement. I mean, you can't say with the fact it will definitely change. Okay, so it may vary according to the data set. Like I took the example of this. Suppose I have 2, 5 in my data set. Okay, it's
So
clear,
quiz
Jana?
one,
And
there is another doubt from quiz one, question number 86. It is mentioned if the population variance of a data set of 6 observations is 50, then
One second,
what
one
is
second. 1 minute actually. You are saying
okay
population variance.
of a data set
Okay,
of of 6 observations is 50? Then what?
50.
Yeah, 50.
Okay, okay.
Then what is the sample variance of each observation in the data set if increased by 5?
Okay, means okay. So can you tell me if you add a constant to a data set, so sample variance or population variance will get changed or not?
Yes.
it will change, sir.
No, sir, it will
No,
not
sir.
change.
It will not change, right? There is no effect of adding a constant on variance or standard deviation. Do you know these things or should I derive?
No, no, sir. Got it, got it. Yeah,
Got it?
recalled. Yeah,
So there
recalled.
is no effect of 5. Okay, let it be. You know this formula, n times of sigma square is equal to n minus 1 times of s square,
Yes, sir.
Yes, sir.
correct? So n is 6 is given to us.
Right,
Sigma
sir.
square is 50. N minus will be 9. oh sorry, 5, 6 minus 1 into s square. So it will be 10. So s square is nothing but 60. Simple. 1 minute calculation.
Sir, actually, activity question 3.3, question
Mhm.
number
And this
5.
n square is equal to n minus 1 s square. This is formula for sample variance.
No, no, no. This is the relationship between population variance and sample variance. Okay, 1 second. I think you had not attended this.
Sir,
Yeah, see, suppose, yeah, I will come to you. No, no worries. Let me finish one topic first. Okay. So, you know what is the sample variance? 1
Yes,
upon n minus 1 summation of xi minus x bar square.
right,
Correct?
right, right,
So,
right, right,
can I write n minus 1 times of s square summation xi minus x bar square?
right, right, right.
Correct. And what is the population variance? We are
1 by
normally
n.
denoting population variance by sigma square. So it's 1 by n summation of xi minus x bar square.
Right, right,
So from where I can write n times of sigma square as summation of xi minus x bar square.
right, sir.
So this right hand side is equal.
Yes, 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 yes.
So I can write the n times of sigma square equal to n minus 1 times of s square.
Oh, okay, okay. Yes, yes,
Okay,
yes,
so
yes.
thing is that if in this equation, if two I mean values of two things, either sigma square s square is given to you, so you can find the value of n. Suppose n and sigma square is given to you, you can find the s or s square kind of things. Okay,
Okay, okay, okay. Understood,
clear?
sir. Understood, understood.
Okay, yeah, yeah. So after
Sir, a
that now,
small
sir,
short note on pie
hello.
charts, please.
yeah, one by one, yeah, yes, please.
A small note on pie charts, sir. Like if the
No,
percentage is given to us, how will we calculate the number in pie
so
charts?
it's okay. It's a simple things, right? Suppose this is the pie chart. Okay, this is the okay. Let me pie chart. Suppose this is the 10%. Okay, this is suppose 40%. 50. Suppose this is the 30%. So far. Okay, suppose this is the percentage of sales percentage of in a company of 4 items. Okay, suppose this is the item A, this is item B, this is item C, this is item D. So it is saying in that year in the company total 1,000 items has been sold. So how many items A has been sold? Okay, so it's nothing
Yes,
but
sir.
10% of 1,000. Correct. So 10 into 1,000 divided by 100. That's all.
Okay,
So
sir.
total 100 items of uh, I mean
A was sold.
A was sold. Okay. Similarly, you can do for B. So B is what? See what it's showing 40%. 40% of 1,000. Correct.
The 40 into 1000 divided by 100.
100 because percentage is what? 40%. I can write as 40 by 100. Okay.
Yes, sir.
Of means multiplication. That's all. Clear?
Okay, sir. Thank you,
Okay.
sir.
So after you, Avinash has raised hand. So yes, Avinash.
Sir,
Yeah.
sir, question number activity question 3.3 and question number 5. Kindly help me to understand this stem and leaf
Okay, Suraj,
activity.
I will come to you. I think Avinash has raised hand. Okay.
Yeah, thank you,
So,
sir.
yeah,
My doubt is on percentiles and quartiles, and
percentile and
mainly,
quantiles.
yeah,
Hmm.
mainly on percentiles. Like there is a kind of difference on calculating this percentage when the total count changes. Like if it's even, there is some kind of calculation, and if it's odd, there's another kind of calculation, and I really can't understand the difference between them. I
Which one?
can.
Can you repeat?
I can give you the questions in a grade assignment. There are two questions like in grade assignment 3.
Mm-hmm.
Uh, like the fourth question is let the data 32, 65, 98, 71, 56, 40,
One
66.
second, 1 second, 1 second, 1 second. Let me open the grade assignment.
Yeah.
Think. Yeah, sorry about this. Grade assignment 3, right?
Yes, yes, yes.
Okay, 1 second. Okay, in which question?
Fourth Yeah, yeah, this one. The fourth and fifth.
Okay, so what is the doubt?
In the fourth one, there is, personal calculation. Uh, how
No, in
would
the
we?
fourth, there is not percentile. It's asking about sample variance.
So, in my question, I think there's percentile. Yeah, so
Oh,
I have a different question over here.
okay, okay. So in the fifth, it might be fifth question.
Just a minute.
See, data set will be different. Okay.
No,
So,
yeah, I'm just trying to get the same kind of question. Just a minute.
yeah, please check that.
It's not both the questions, sir. It's like suppose we have 10 observations such that 37, 26, 30, 26, and 29, 90. Calculate 10th, 50th, and 100 percentile.
Yeah,
Um,
this is the question. Are you able to see my screen?
yes, sir, but the total number of observations is like you can
Yeah,
take
it's a
this question
different.
itself. Yeah,
Yeah.
yeah, you can take this question itself, but
Mhm.
just get me the understanding. Let me understand difference between like if here's 7 observations, like what
Mhm.
if it's like 10 observations, and how do we calculate for how it
Okay. So,
changes if the total changes, total count changes? Yeah,
no,
frequency.
no, no. So can you tell me how can you compute the percentile? What is the step to compute the percentiles?
So P is a percentile is the count they have given. If it's 10 percentile, which we have to find is like we have to
Mhm.
get P is as 0.1.
10. Okay.
Yeah. So N, if we have to get the total number count in N, and
Mhm.
we have to find the NP, right?
Okay.
Yeah. After finding the NP, we have to get the value which corresponds to the value of NP.
That's all. Okay.
Yeah.
See, first is we need to arrange the data in ascending order.
Ascending order, yes.
Correct.
Yeah.
Second thing is that we need to find the value of NP, N into P. If
Yes.
so, there is two cases. If NP is in integer, is not integer,
Okay.
value of NP is in decimal, so we have to take the value in the position of NP plus 1th observations. Okay.
Okay. If it's not an integer, we have to take NP plus 1 as well.
1th observation
Okay.
of
Okay.
my data set, right? Suppose
Okay.
NP is coming out to be 2.1. Okay.
Okay.
So this 2.1 is not in integer.
Yeah. It's
So we have to take the NP plus 1th observation, means we have to take this next. So observation at, I mean, in the data. So what will be the next? Third one.
third one. Yeah.
Okay. So third observation we have to take from the data set. And
Okay.
suppose NP is in integer. Okay. Suppose
Okay.
it is coming out to be 2. So we need to take the average of observations at the position of NP and NP plus 1. That means we need to take the average of second observation plus third observation. That will be the percentile. Okay. Suppose I have data set 2, 1, 3, 5, 4. Okay.
Okay.
Now, so first step is I need to arrange the data set in ascending order. So 1, 2, 3, 4, and 5. It is clear so far?
Yes. Yes, sir.
Now, what is the value of n?
Uh, okay. Let's take it as 10. I mean, 10th percentile. So 0.
I'm asking about what is the value of n here?
5. 5. 5.
5. Okay. Let's say I'm interested to compute the 20th percentile. Okay.
Okay. Fine.
So value of p will be 0.20.
Yeah.
So what is the value of np? 5 into
20.
0.20 means
One.
1. So is
Yes.
it in integer or decimal?
It's a decimal. See, in integer. Integer.
It's an integer. That means we need to take the average of the first observation and second observation. So first observation is 1, second observation is 2. So it will be 1 plus 2 by 2. It will be 1.5. So 20th percentile of this data set is 1.5.
Right.
Okay.
Okay.
Suppose I'm interested to compute the 30th percentile. So value of P will be 0.30.
0.30.
So NP will
0,
be what? 5 into
5,
0.30. That means 1.5.
1.5.
Yes.
It's in
Yes, sir.
decimal. So we need to take the next smallest, I
Second,
mean integer.
That is
So
equal to
second observation. So second observation is 2.
2.
So 2 is the 30th percentile of this data set.
Sir,
Got it.
Okay.
why you have not, sir, just a second here.
Hmm?
Why you have not taken the first and second observation? Because in above case you have taken observation and divided by 2. So why you have not taken here in the first and the second
Okay, Bhavya.
observation?
Let me tell you. Just go in the week 3 lecture. Okay.
Sir, I have gone through all those lectures, but I know
Okay.
because
Hello.
yes, sir.
Yeah.
Yes, sir.
So just rewatch the lecture 3.5. Okay.
Sir, I
How
have
we
gone
can
through that.
compute the percentile of any data set.
Sir, I have gone through that, but
Mhm.
I am not sure. I am not clear about it. We are going, why we are not taking first and second term when we are getting fractional or decimal point here.
Okay. So tell me. Then why we are taking the average at this point?
পরে কথা বলছি
It's also possible I can take the first observation.
Sir,
So why we are
হ্যালো
taking the average?
So we are taking the average because it's NP plus 1.
No. I'm asking to my value of NP is coming out to be in integer. Then why we are taking the
yes.
average here?
The average we are taking,
Hmm?
sir,
By
because because there are only five observation,
Okay.
and if observation is odd, then we need to, the number of when number of observation is odd, then we need to take for the
Okay.
number,
Okay. Let me
take the
one
first
second. One
and the
second. Okay.
second.
Okay. You are saying, suppose I have this observation, 4 observation. Okay.
Yes,
So n is 4.
and is 4.
Suppose I'm saying compute the 50th percentile.
Yes, sir.
Okay.
Yes, sir.
So here, what will the 50th percentile? What will the value of NP? 4
Sir,
into
it we will
0.5.
take here second and third. Yes, sir.
Okay.
Third
Why we are
observation.
taking the second average
Second
of second and
observation
third?
plus.
According to you, as you said, this is the odd number. That's why we are taking the average.
Yes, sir.
Here I have taken the even number. Again, why we have to take the average?
Sir, because to find the median, we need to take average.
Okay.
Because 50% is a median. So to find median, we
Okay.
need to
So
take an
according to
average.
this, suppose 50%, if I'm going to compute the 50th percent of this data set, then again I have to take the median.
Yes,
I
sir.
mean, again I have to take the average.
yes,
Yes,
sir.
sir.
Okay. Suppose, so for this data set, once again, let me erase the things. You are doing just arguing and nothing else. Okay.
sir kindly
So
help me to understand this
n is 5. So P is 0.5. Yeah, I will come to you, Suraj. One minute. Let me finish this. So value of NP is what? 5 into 0.5, that means
And P
2.5.
is 2.5. Yes,
So
sir.
according to you, I should take the average.
Sir, now there is 2 point because in lecture there was tell us that second observation plus third observation, because it is point 0.5 and fractional will be converted to the next point.
what you are saying? I mean, I'm not getting your point. What you are trying to say here?
Sir, in the video we were asked that if there are two decimal points,
Hmm.
then we will take second observation as well as the third observation and do the average of both the, because it
If
is
it's
in
a decimal or it's an integer?
if it is in
Yeah,
fractional, think
only
so.
thing, if it's in fractional, then we have to take the next smallest integer. So next smallest integer is nothing but the third observation, which is
Third
3,
option.
which is the median of this data set, middle observation. So try to relate
Okay, sir.
here why we are taking the third. Okay,
Okay,
if
sir.
you will take the, in case of 2 plus 3 divided by 2, then it will be median or not. Okay, if you are again
Okay,
doubt,
sir.
so you can rewatch the uh,
Okay, sir.
revision sessions and all things. Okay, don't disturb to all. Is it clear for everyone? Percentile who has asked to me? I think it's
Thank you, sir.
percentile is clear. Percentile thing is clear to
Yes, sir. Thank you, sir.
Yes, sir.
okay. So after once
Sir,
I think Arifa has doubt. Yes, Suraj. Yeah, Suraj. Just wait for a minute. I will come to you. Okay. No, no issues. Okay. After
Yes, sir.
Arifa, there is Vansika, and after Vansika, I will take the doubts of Suraj. Okay. Yeah, Arifa, please tell me.
Sir, am I audible, sir?
Yeah, yeah, you are audible.
Okay, sir. In the measures of dispersion, I
Okay.
understood range, variance, population variance, and sample variation. Sorry,
Okay.
sample population, but I didn't understand standard deviation. It says kg square and also I didn't
Okay,
understand
okay, okay.
that part
Yeah,
of
yeah.
it.
Okay, okay. I will come to you. You know what is the standard deviation? It's the square root of the variance, correct?
Yes, sir.
It's the square root of variance. So see, what variance tells us? It tells us measure of dispersion, right? See, not, I mean, variance is a measure of dispersion. What variance tells us? It tells us, if you see the formula carefully, what meaning of this? It tells us the spread of the data set from its mean, correct?
Yes, sir.
It tells us that what is the spread, what is the variation of the data set of each values of the data set from its mean, correct? This tells us variance. And same things for the variance standard deviation, which is nothing but the square root of the this variance. You are talking about the kg square. Okay. So suppose from this example, we will be able to know what is the role of standard deviation. Okay. Suppose x is some weight of let's say person weight of 5%. Okay. Suppose weight of 5% is given to us. Okay. So I can compute the mean. It will be again something, let's say it's coming out to be 58 kilogram. I mean, I'm just assuming it may possible your data set and mean is coming out to 58. Okay.
Okay, sir.
So from this exercise, I can compute the xi minus x bar.
Yes, sir.
Yes,
So
sir.
what will be the unit for this xi minus x bar? Kilogram.
Kgs. Yes, sir.
And what will be the value of xi minus x bar square?
Kilogram square.
Kilogram
Kilogram
square.
square.
Are if it is clear so far?
Yes, sir. Yes, sir.
Now, what is the role of standard deviation? See, suppose my original data set was in kilogram, correct? So it will be
Yes, sir.
easier for me, for us, the I mean, the measure of dispersion, if it's in, again, it's in original units, then it will be easier for me to compare the things, right?
Yes, sir.
So this is about variance, and when you will take the square root of the variance, then my original, I mean, measure of dispersion will be in original
Understood,
unit,
sir. Yes, sir.
correct?
Yes, sir.
So my, that's why standard deviation comes into the picture. Okay, it's
Thank you,
again
sir.
measures of dispersion, but it's nothing but the positive square root of the variance. Okay,
Yes, sir. Fine, sir. Thank
clear?
you, sir. Yes, sir.
Okay, okay. So after you, Vansika has raised hand. After Vansika, I will take the doubts of Suraj, then Bhavya. Okay. Yeah, Vansika, please. Go ahead.
Yes, sir. Am I audible?
Yeah, yeah, you are audible.
Sir, I have a doubt in from the qualified exam.
Okay.
One question from there. The question is choose the correct options.
Hmm.
First was if the large values of variable x tend to be associated with small values of variable y, then the
Okay.
correlation between x and y will be positive.
Okay.
So it is wrong. I understood that.
Mm-hmm.
The next option was if the correlation coefficient between two variables is zero, then the
Mm-hmm.
variables are independent.
Okay.
So it, malab, it should be right. Why is it not correct?
Okay. And another option, it
Third
will be, I
option
think,
is correlation.
variables are independent. Next option is right.
Yeah, third option
Then
is correlation coefficient is a unitless measure of association. This
okay.
is correct. Okay. And fourth is correlation coefficient always lies between 0 and 1. So this is
That
not
is
correct
the
because
another again wrong.
yeah, it lies between minus 1 to 1. But in second option, I
Mhm.
am having confusion that why it is not independent if the correlation coefficient between two variables is 0, then it can be, we can
Okay.
say
Okay.
that
Yeah. Yeah.
the
Yeah.
two variables are
Yeah. I will come to
independent.
this point. Can you tell me what correlation coefficient tells us basically?
It tells us the relation between two variables,
Only relation or a linear relation?
linear relationship. Yeah.
Correct. Suppose I have a data set. Okay. I will go. I'm going to. Suppose I have a data set. Let's say -3, -2, -1 something. 1, 2, 3, and another data set is y. Okay. So it's let's say it's a 9, 4, 1, 1, 4, and 9. Okay. Let me, yeah, 1 second. You can see
So what happened to the board?
what happened for.
No, I can't see the board.
Yeah, yeah, yeah. I'm going to share the screen. Now is it visible? Okay. Suppose I
Yes.
have data set x. Okay. And another variable y. Okay. So my x is, let's say, -3. Okay. -2, -1 is there, and 1, 2, 3. Okay. And y is nothing but, let's say, 9, 4, 1, 1, 4, 9. Okay. So
Yes, sir.
what is the relationship between y and x here?
Squares. Yes.
Square, right? Y is nothing but x square. Correct.
Yes.
Now
Yes, sir.
let me compute the correlation between these two. Suppose this is x data set and this is y data set. It is 0. Correct.
Yes, it is
Yes, sir.
0.
So come to the point. Here my correlation coefficient between x and y was 0, but y and x is related as y equal to x square. Correct. So correlation is 0 means it's not linearly related, but there might be a relationship, okay, between the two variables. If the variables are independent, then correlation will be 0. I mean, okay. So if it's correlation 0, that doesn't not means variables are independent. Okay. There is no linear relationship between those two variables. It might possible there is some relationship. Okay. So here my x and y is connected by by the relationship y equal to x square. It is clear.
Okay.
Yes,
Okay.
sir.
Yes.
And
Sir,
you were
can you please
talking
show
about
that?
the large values of this one, right? So I'm going to just draw a chart. So far, it may help to you guys. Suppose this is x axis. So I'm assuming, suppose x bar, I mean, for a data set, suppose x bar is there and suppose y bar is there. Okay. This is y, this is x. Okay. So suppose, second, this is the some, my data set is there. Okay. Some scattered. Okay. So this is the my x bar and this is the my. Okay. So just tell me, what will be the value of xi minus x bar here? It will be negative or
Negative.
positive? Negative.
Yes, negative.
Negative.
And yi minus y bar,
Negative.
So
negative,
negative.
correct? And in this region, what will be the xi minus x bar?
Will be positive.
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 And yi minus y bar?
Negative.
Negative,
Negative.
correct? And what about this region? Xi minus x bar?
It will be
Positive.
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 And what about yi minus y bar?
Positive.
Positive.
Positive. And what about this xi minus x bar?
Negative.
Negative.
Negative or positive?
And positive.
Negative. And yi minus
Negative
y
and
bar is
yi minus y bar will
Positive.
be positive.
correct. Now, come to the formula. What R is there? Covariance between x comma y divided by small x,
Standard deviation.
standard deviation of x. See, be careful. If you are using in the denominator sample standard deviation, then you have to use the sample covariance formula, right? Are you getting?
Sir, what is sample covariance?
See, what is the small sx means? Sample standard deviation.
Yes.
Small sy means sample standard
Sample.
deviation of y.
Yes.
So that means you have to use the sample covariance formula in the numerator. You can't use 1 minus, I mean 1 by n, okay? Why? Why I'm going to tell you. What is the Sx? I can write 1 upon n minus 1 summation of xi minus x bar square, correct?
Yes.
And 1 upon n minus 1 summation of yi minus y bar square.
Yes.
So these 2 1 minus n can be cancelled out by this, because square root 2
Yes,
means
sir.
2. So in the denominator is square root of 1 upon n minus 1, square root of 1 upon n minus 1. It's 1 by n minus 1 will get cancelled out.
Yes.
Are you getting my point?
Yes, sir.
So there is another correlation formula. If you remember, it is nothing but summation of xi minus x bar into yi minus y bar divided by square root of summation xi minus x bar square root of summation yi
Y
minus
minus Y
Sir,
y
bar.
bar.
on the
This
both
is the formula.
sides, numerator and denominator, it is multiplication, right?
Yeah, it's a multiplication.
Okay. Okay.
So thing is that if you use the population covariance formula, then it will be 1 by n, correct? And suppose instead of sample standard deviation, I'm using population standard deviation, it will again be 1 by n. 1 by n, it will get cancelled out. I mean, meanwhile, at the final step, I will get this formula. Okay. Now, come to this picture. What will be the product of these two? Product will be positive or negative?
Positive.
Positive.
What about this one?
Negative.
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 One is multiplication of minus 2 into plus 2 will get the value of in negative, right? What about this? Product is
Positive.
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 what about this? Product is
Negative.
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 So now it's clear. If large values of x is related to small values of y, or product of xi minus x bar into yi minus y bar is positive, then my correlation will be positive, because in the denominator things are already positive because it's a square. So we have to careful about the numerator things. Okay. So it's clear. I mean, how we can relate the things.
Yes, it's clear.
Yeah. Yeah. Anything else? Arif, I think our Arif has out. Yeah.
Um, so me.
So Vansika.
Sir,
Yes.
so please,
Yeah, yeah,
the
Suraj. Yeah, yeah. Sorry about that. You are waiting. Yeah, please tell
question,
me.
activity question 3.3, question number 5.
Okay, 1 second. Let me open the portal. Activity. Let me share my screen. Activity 3.3, right?
Yeah,
Okay.
question number 5. Is a stem and leaf.
Okay. What is the doubt?
This one,
Yeah.
is stem
Okay.
and
What
leaf.
is doubt?
Actually, I didn't understand. Kindly help me to understand
Okay.
the
You understood the meaning of see this key 6 oblique. I mean 6 given 4 means, I mean this 6 in the stem and 4 in the leaf. This represents the 64. Okay.
okay.
So 5 1 represent the 51, comma 52, 54, 55, 57.
Okay.
Okay, okay, one second, let me.
Kindly explain on board. Okay.
Okay. Suppose I'm taking some random data set, okay? I'm not going to take
Okay.
that. I will explain to you how
Okay.
I can. And be careful, stem and leaf plot is already is in ascending order, okay? Suppose I'm going to make the stem and leaf plot for this data set, okay?
Okay.
This is a stem and this is the leaf, okay?
Okay. Okay.
And I'm saying meaning of 1 given 4 means 14. So that means I have 10, I will write 1, 0 here. After that I have
12
12,
1 2.
2. I have 30, 3.
Yeah, 3
Then I have 2,
2.
21.
Okay.
So stem will be changed. Okay. It will be
Okay.
1, 2. Again it's the 33. So it will be 3, 3, 35, 5.
Okay.
Okay. That is something. So here you have data set in the
But
stem
the
and leaf plot.
question is, what is the median of this age?
Yeah, simple things. See, how many observations you have? You can count the
Yeah,
observations 5, 4,
yeah.
9, right? 9,
9,
6,
9, 6,
15,
15,
20
15,
observation, right?
20 observation.
So
The
if you have even
median
number, yeah,
mean is 4,
me,
5.
what will, no, no, see, tell me, what will be the median? If you
Uh,
have even number observation,
yeah,
then
how many repetition of the number? How many times?
what do you mean by repetition?
Mean,
It's asking about median, right?
okay.
So what's the median?
Number of observation.
How can you compute the median for any data set?
Number of observation plus divided by 2.
See, to compute the median, we have two things. First step is we need to arrange the data in ascending order. Okay.
Okay.
But if you see carefully, in the stem and leaf lot, observations are already in ascending
Ascending.
order. Okay.
Okay.
Now we
Okay.
have to see what is the n. N is odd or even. Okay.
Okay.
If n is odd, then what is the formula? Median will be n plus 1 by 2.
2.
Correct.
Correct.
And what
Yes.
about even?
N by
Very
2
good.
and
Average of n by 2 plus n by
plus
In
2
N by
plus
2 plus 1
divide by 2.
one
divided by 2.
Correct.
divided by.
So
Okay.
what is the n in this case? Okay, let me come to this. What is the n is 20?
20 divided by 4. N is 5.
Why, why you are doing 20 divided by 4?
Number of observation, I think 4.
Why 4 number of observation? Why you are saying number of observation is 4?
No.
How
1, 2.
many observations we have?
Observation is 60. 1, 2,
I'm
3.
asking about how
20,
many observations? 20, right?
20
20 observation.
So 20 is even or odd?
20 even.
even.
If 20 is even, then which formula we have to apply?
N by 2
N
plus
by 2.
N by 2 plus 1 divided by 2.
Okay, right?
Yes. 20 by 2,
So
10.
so it will be 20 by 2. That means 10th observation. I mean, it's a n by 2th observation actually. Okay, it's n by 2 observation. So what is the 10th observation? We need to take the average of 10th observation plus 10 plus 1, 11th observations
11th observation.
divided by 2. So what is the 10th
Yes.
observation in data set?
10th observation.
71.
Yeah,
You found.
71.
71 and
And
73.
11th observation is 73. Correct. So
Correct.
71 plus 73 divided by 2, which is will be 4. 144 divided by 2. So
60,
22.
70.
72 is the median. That's all. So median is nothing but it tells us the middle most observation. If n is odd, suppose in this case my n is odd, right? N is
Okay.
7 here. So median is nothing but 21. You can leave these three observations, these three observations. That's all.
Okay, thank you very much.
Okay, clear it?
Thank you, sir. Thank you.
Okay, nice. Thank you. So after you, Ronak
Quiz one.
has raised hand.
Quiz one.
Ronak, you are there?
Yes, sir.
Yes, sir. Quiz one, 85 question number, sir. The cumulative frequency, can you explain about the cumulative frequency?
I don't remember the exact question you are saying.
I'll tell, yeah.
So
The question is, the data set consists of three distinct observations, say A, B, and C. The sum of their
okay.
frequencies is 100.
One
And
second, one second. Some 1 minute, 1 minute. Suppose frequency for this is f of a. I'm saying f of 1, f of 2, f of 3, and you are saying sum of the frequencies are 100. Okay.
And relative frequencies corresponding to A and C are 25% and 35% respectively.
Okay.
Find the cumulative frequency of B and C.
Cumulative frequency of B
and C.
So what
B
is the
and
meaning
C.
of cumulative frequency? I mean, we need to find the f2 plus f3. Okay.
Yes.
Now, so this is the relative frequency.
Yeah.
So what will be the frequency for A and B, A and C?
25 and 35, sir.
Okay. See, some, relative frequency is what? Yeah, correct. Relative frequency is nothing but frequency of divided by total number of observations. Correct. Yes. So from here, I can find the frequency. Frequency is nothing but the relative frequency into number of observation or not. Can I do?
Yes.
Okay. So f of 1 is given to me as see, relative frequency for A, I'm denoting as RF1. So it's a 25%. That means 0.25. What is the total number is 100.
Yes.
So frequency for A is 25. Correct. Now frequency for C I can compute because I have relative frequency. I have total number of observations. See, total number of observations is nothing but when we are going to add all the frequencies. Okay. So from here I can compute the frequency for C. What will be this? 0.35 into 100. That means 35. Correct. So frequency for A and C are 35 and 25. Correct. In the question you are saying, see, we need to find the f2 plus f3. So we need to find the frequency for B. Correct. So you are saying sum of all the frequencies is 100. Okay.
Correct.
So f1 is 25 plus f2 plus f3 is 35 is 100. So from here f2 will be 100 minus 35 plus 25 is 60. 40.
Yes, 40. Yes.
So 40 plus f3 is 35. So 75 is the clear.
Yes.
Okay. So
The cumulative frequency means we need to add the cumulative means we have to
we have to accumulate the thing. We have to think about what?
Thank you.
Okay. So after you, Runak has raised and yes, Runak.
Yes, sir.
Yeah, yes, please.
Sir, I have doubt in mock test question, sir.
Which mock test?
Mock test 2, question number 3.
Mock test, weekly mock test you are talking about?
Yes, sir. Mock test 2, sir.
This one?
Question number 2. No. No, sir. Not this one.
Okay, which mock you are talking about? Second, let me. This mock test 2. This question number 2?
Yes, sir.
Okay, so what is the doubt?
Sir, I'm not getting the same answer.
So it is asking about then difference between the sample variance of new data set and sample variance of old data set. Okay, so can you tell me? Its question is saying by multiplying each of the numbers 4, 5, 3, 4, 5, 7, 11, and 30 by 4, then adding to 7. So first you have to find the sample variance for this old data set. Okay, 4, 5, 7,
Okay.
and 11 and 30. So I'm going to use Excel sheet. 1 second. Stop my screen for a minute. Yeah, just a second. So just tell me what are the observations? 4, 5,
4, 5, 7,
11, and 13, right?
11, 13.
So
Yes,
what's
sir.
the sample variance, right?
Hmm.
So sample variance for this data set is 15, correct? And we have to
Yes, sir.
multiply it by what?
4.
4. So see, I can, first thing, you can multiply it by the 4 to all the observations, then you can right, you can find the new sample variance, right? Or you can apply
Yes,
the
sir.
properties. There is a property, right? Property is what? Suppose I have old a data set x1, x2, xn. Okay, suppose I want to add
Hmm.
a constant c to all the observations, then what will be the my new variance? Is equal to old variance.
Plus C
5 plus c.
into C.
In the case of variance, is variance is affected by adding a constant?
No, sir.
No, sir.
No.
Is it clear for
No,
everyone, or
sir.
should I derive the things? Ronak, do you know these things?
Yes, sir. I know, sir.
Okay. So suppose I want to multiply it by a constant to this all the observation, then what will be my new variance?
Multiplied by the constant.
C square into new old variance. Is it clear for everyone, or should I derive? I'm
Yes.
asking if you want to the
Yes, sir.
things, these things from where, then I can tell you. Okay. Okay. So this is the property. First, let me finish this question. Okay. So we have to multiply it by which 4, right?
Yes, sir.
Okay. So if you multiply by 4, that means I need to multiply it by 16. 4 square. 4 square into 15, right? See, I'm uh 16 into 15. So this is 240. So it's asking about difference between new variance, sample variance, and old sample variance. That's all. So 225. So there is no effect of adding a constant. Okay. Now this is by the properties of variance. Another approach is, see, this is the simpler approach. Another approach is you can multiply it by 4, okay, to all observations. Then you can find the sample variance. This is the another approach. Okay. So suppose this is the this data set I got. This data set I got after multiplying by the 4. Now let me compute the variance, sample variance of the data set. Okay. So it's a again 240, which is the same this one. So the simple thing is you can apply the property here. Okay. So there is
So
no
after
effect of,
adding, we have
yes,
to multiply with 7. No, no, after multiply with 4, we have to add with 7 in
yeah,
every number.
yeah. But Ronak's thing is that adding a constant does not affect the variance.
Total. Yes.
Okay, let me derive the things. You people are getting confusion. Suppose I'm taking the example of population variance. 1 upon n summation of xi minus x bar squared. Suppose this is my old data set. Okay. I have data set xi. So xi is nothing but x1, x2, xn. Okay. So suppose mean of this data set is x bar. Suppose I'm going to add a constant c. Then my new data set will be x1 plus c, x2 plus c, xn plus c, or not. What will be the new average? X bar plus c. You know this property. Are you getting these things or not? Suppose I have data set 1, 2, 3, 4, and 5. What will be the mean of this data set? 15 by 5, it is 3, correct?
3.
Suppose I add
Yes,
a
sir.
value 2 to all the observations, then my new data set will be 3,
And
4, 5, 6, and
5,
7. What
7.
will be the mean of this data set? 12, 6, 18, 25 by 5, which is 5, correct?
5.
This is
Yes,
my
sir.
old mean. This is my
New mean.
new mean. So is it x bar plus 2? Same. See, this is 3. This is 3. I got the new mean as 5, correct? So
Yes,
I
sir.
can say y bar is the 3 plus 2, x bar plus 2. Can I say or not?
Yes, sir.
So thing is that, so this is the small data, okay? This was the small data. You can simply calculate the mean again. But thing is that suppose you have a large data set, you have 20 observation, then computing the mean of adding a constant to all the observation, then computing the mean of all the observation is a tedious task, right?
Yes.
So that's why this property, I mean, we can use the this property. So for this x1 to xn, suppose I want to add a constant c, which is I'm going to say here I in this example I took as 2. Then what will be the new mean? So new mean I can say x bar plus c or not, correct? I can say
Sir.
now.
Yes, sir.
Suppose I want to compute the new variance after adding a constant. So my new data set is yi minus y bar whole square, correct? So what is the yi? Xi plus c, correct? I am adding
Exciting.
minus. What is the y bar? X bar plus c,
Bar.
correct? I can write 1 upon n
Yes.
summation I to n xi plus c minus x bar minus c whole square. So c will get cancelled out from here. So I'm getting xi minus x bar whole square. What is this? This is old variance. So is this clear for everyone? When I will add a constant to all the observation, then my new variance is same as the old variance. There is no effect of adding a constant to the observations. Okay? Is it clear for everyone?
Yes, sir.
Now,
Yes, sir.
suppose I'm going to multiply it by a constant. Then it will be 1 upon n summation I to n c times y bar and sorry 1 upon n summation I to n. Okay. So it will be c times of xi minus c times of x bar. Correct. So it will be 1 upon n. C will be outside. It will be c square summation xi minus x bar square. So it will be c square times 1 upon n summation xi minus x bar square is
Assignment.
c square into old variance. So when you will multiply it by a constant to the old data set, then new variance will be c square times the old variance. So here uh, uh, we had to add 7. So there is no effect when we will add 7, but we have to add the 4. I mean, we have to multiply it by 4. So it will be 4 square into old variance. So 4 square 16 into old variance was 15. It is clear now?
And told. Yes, sir.
Okay.
Yes.
So after you, Vansika has
And
risen.
sir,
Yeah.
I have one more doubt.
Yeah. Yes. Yes, Rona.
Sir, that association between two variables, I didn't understand that concept. Sir.
Which
Week
one?
4. In week 4, association between two variables.
So association between two categorical variables or two numerical variables?
Yes, sir.
I mean, which one? There are
Sir, I didn't understand that that particular.
association between two categorical variables.
Yes, sir.
Okay, let me take an example from. Let me see. Is there any question or not? Is there any question in mock or anywhere? Any one of you are aware about this?
Sir,
That
there
I
is a
can take.
question and quiz one, sir.
Okay, so I'm going to explain the concept. Okay, yeah. Okay, what was the question? Can you tell me? Just tell me two
Yes.
variables. So you are going to, okay, so tell me which question.
I have
Yeah,
one question, sir. That two
where?
variable is,
Where it is?
it was, I don't think so there. Actually, it was in mock test question, sir, which I wrote in last week exam. Last.
Okay, okay. One second. Let me, yeah. I think this okay, suppose
Can I
this is,
read the question?
yeah, okay, tell me.
So two variable, that age group in year
Hmm?
and willing to buy.
Willing to buy? Your voice is breaking,
And
bro.
the second variable is, the first variable is age group in year.
Mm-hmm.
So there was less than 18,
Okay,
19 to 30, more than
okay,
30.
okay. More than 30.
Yes, sir.
Okay. And what is the next variable?
And next variable is willing to buy.
Okay, willing to buy what? Something car or let's see. Okay, whatever.
Yes.
So it will be something S or no?
The number, sir. Yes. No, then there was an
Okay, so I'm
first
just going to take some
40,
randomly, okay? I'm
okay.
Sir,
just going
it's
to
willing
explain.
to go abroad for higher studies.
Okay, so I'm going to take, I take some random things. I'm just going to explain the things, okay? So see, first of all,
Okay.
we see what is the meaning of association. I mean, suppose change in one variable can tells the change in another variable, right? I mean, suppose knowing the information in one variable, if gives us the knowing, I mean, gives us the information about the another variable, that means two variables are associated, right? Now, so we know we have two data set, categorical, numerical, right? So here I have two categorical variable. First is willing to buy, and it has two category, yes and no. Second variable is age group. It's not age. It's a category. There is a category of less than 18 age. I mean 18 years, and there is another category between 90 to 30, and there is another category of more than 30 years. So we have three categories. So this is the categorical variable and this is the categorical variable. You know what is the categorical variable? In which I cannot perform any meaningful mathematical operation. Okay, like phone number, gender, blood group, jersey number, and all this. So far it is clear. Now, so association between two categorical variables we can find by the row relative frequency or column relative frequency. Correct? So thing is that I can use any method. I can use whether a row relative frequency or I can use the column relative frequency. You know what is the relative frequency? Relative frequency is nothing but frequency divided by total number of observations, right? So here I have A, B, C, D, E, F. This is less than 18. This is category of 19 to 30. This is more than 30. This is yes, this is no. So how I can compute the row relative frequency? First, I need to compute the row total, because what is the relative frequency of any observation? Frequency of that observation divided by total, correct? Here I am emphasizing on the word row relative frequency. So I'm interested in row total, correct? So what is the row total for the first row? Less than 18, A plus B. Correct or not? Hello.
Yes,
Yeah,
sir.
correct, sir. Go get sir.
Sir,
Okay. What
C
about the
plus D
C plus D, E plus
plus F.
F? Okay. What about this total? A plus C plus E and B
Yes, sir.
plus D plus F. What is the grand total? A plus B plus C plus D plus E plus F. Now, I'm interested to compute the row relative frequency. Okay. So what will the row relative frequency for this first, for this row? I can compute frequency, right? Divide by total, correct?
A plus.
A
Yeah, yeah.
divided by A
A
plus
given by
B.
A plus B.
Suppose
Yeah.
I'm interested to compute in percentage, so I will multiply it by 100. That's all. Okay. D divided by A plus B into 100, correct? Similarly, for this, I can do C divided by C plus D into 100, and for this, D divided by C plus D into 100. It is clear or not? And for this row, E divided by E plus F into 100, and for this, F divided by E plus F into 100. For the last row, A plus C plus E divided by this total, A plus up to F into 100, and this A plus up to F into 100. So far it is clear how we can compute the row relative frequencies.
Yes, sir.
It is clear for everyone now. So thing is that, so row relative frequency. Similarly, I can compute the column relative frequency by dividing A divided by A plus C plus C, B divided by B plus D plus F. Similarly for the other. So thing is that either you can compute the row relative frequency or column relative frequency. Now, if all the row relative frequencies, so row relative frequencies are what? Are, let's say for less than 18, I'm saying row relative frequencies are just let's say it's A percent, it's B percent, and for 19 to 30 it's C percent, it's a D percent, and more than 30 it's coming out to be let's say E percent, F percent, it's a capital, and for the total, let's say it's coming out to be J percent, and it's a K percent. Now we need to compare the row relative frequency. Suppose this all row relative frequency, okay, this one, this rows, and this rows, okay. If this all the row relative frequencies are approximately same, then there will be no association, okay. And if these row relative frequencies, these row, this, if some of the these row relative frequency have significant difference, then their two variables are associated. Is it okay, or any doubt in this?
Yes, sir. Understand, sir.
Understand? You can
Yes.
plot the there is a stacked bar chart, okay. So in the stacked bar chart, see you can as you can remember, ma'am took the example of female and male. So I'm going to just plot, I mean, going to give you a general idea. Suppose this is bar of female and this is bar of male. Okay, let's take this one. Yeah, one second, one second. Let's take the this. Let's say. Okay, suppose I have stacked bar chart. I'm going to plot a stacked bar chart here. Okay, let's say 100%. You know 100% stacked bar chart. This is 100%, this is 0%, this is, I can plot something like that. Okay, suppose this is less than 18 bar, the bar of 90 to 30, this is bar for more than 30. Okay, so suppose I did not compute the data set, but yeah, I'm just going to give you general idea about the chart. Okay, suppose this green region is for going for the willingness, I mean they are interested to purchase car. Okay, And for this, suppose this is this green region is again to purchase car, and more than 30, and suppose this is let's say this region is to purchase a car, and this red region is they are not interested to buy a car, and then this red region is they are not interested to buy a car. This red region is they are not interested to buy. Okay, so yeah, can you see? If you can see, so either row relative frequencies, or you can plot by the column relative frequency as well. So things are significantly different, right? These all
Sir.
are not approximately same, right?
Yes, sir. It's different.
That means there is
Association.
association. See, I'm just plotted just hypothetically. It might be there is no association, but I'm just wanted to give you idea by a chart. So here you can see the change in one variable. So one variable is age category, right? So when I'm going to change in one variable less than it this one less than 18 to this group, then this group. So I can see there is a significant change in this y-axis, right? What is y-axis? Willingness to buy. So there is a significant change, right? That means variables are associated. This is for the categorical. Is it clear for everyone, or any doubt in this?
So one more doubt in the same question, sir.
Yeah, yes, please. What?
The statement is given if all row relative frequencies are similar within each column.
Hmm.
It implies that all column relative frequencies will also be similar within each row. What does that
Yeah.
mean, sir?
Okay. So here you have two columns, yes and no.
Yes.
Just assume these all row relative frequencies are same for each. For these all row relative frequencies are same. Okay. Okay. Let me give you another example. Suppose instead of A, it's a 10. Instead of B, it's a 11. Instead of, let's say it's a 21, and instead of C, it's a, let's say 9.3. Okay. And instead of D, let's say it's a 20, and E, it's a, let's say 9%, and F, it's a, let's say 20.2. Okay. And say it's again 9.5, and let's say it's something 21.3. Let's say it's a 10.1. Okay. So these all row relative frequencies are approximately same, right? All are approximately same or not?
Yes, sir.
It's a 10%. See, in this column you can see it's a 10. See, okay, 1 second. For the first, it's a for the first one, we go on the new page, so that for the first it's a 10%, it was 11%. Okay. And 9.3 9.3%, it was 21. I'm saying it's, let's say 20%, then 9%, 20.2%. This, suppose this is 9%, this is suppose 20.2%, and 10.1, 21.3. Suppose this is 10.1%, this is 21.3. So the row relative frequency, this one, for this row are approximately same, approximately similar. Is about to similar or not?
Yes, sir.
So what is this? This what was the statement? Hello.
Yes, sir.
Yeah, what was that statement?
If all the row relative frequencies are similar within each row, it
In each row.
implies
Okay, 1 second.
yes.
So either here all the row relative frequency are similar in each row,
In each column, sir.
in each column. Okay, you are saying in each column. So this is 10%.
Yes, sir.
This is 9.3%, 9%, 10.1%. So this is the first column. This is second column.
Yes, sir.
So this row relative frequency is same for each column.
Yes, sir.
Correct.
Yes, sir.
This is my total. This blue is my total row relative frequency. But if you consider a single value in each column, 10%, 9.3%, 9%, 10.1%, it's similar in this column, and this value is similar in this column.
Yes, sir. Yes.
So here I have computed the row relative frequency. Similarly, when you will compute the column relative frequency, so that column relative frequency will be same for each row.
Yeah. Okay,
Okay,
sir.
got
Got
it?
it, sir.
Okay.
Yes.
So after Ronak, Vansika has raised. Yes, Vansika. Vansika is not there. So
Yes,
Vansika,
sir.
Jyoti is there. Jyoti Lakshmi.
Hello.
Yes.
Am I audible?
Yeah, you are audible. Please go ahead.
Sir, so in that same question only, can you explain with an example that where the two variables are independent, where the two variables will be independent?
You can take any data set, right?
So for example,
See, then I have to take a random, then I have to think about the data set. Okay. So it's possible like for a, suppose you have some X observations and observations for another Y variable Y, and you have computed, and there is suppose there is linear relationship, something, any linear relationship, and correlation is coming out to be zero. I mean, correlation is coming out to be zero, that means there is no linear relationship. There, so thing is that this statement is not true for all the time. Okay.
yes, sir.
If X and Y are independent, then correlation will be zero. That is the something. I mean, this statements you will yesterday see. X and Y are independent means what? Converse is true. If X and Y are independent, that means there is no linear association. There is
Yes,
no
sir.
association. Then I can say covariance between X and Y is zero. I can say or not?
Yes, we can say.
Covariance, we can say if covariance 0, then what is R? Correlation. Covariance divided by standard deviation of X, standard deviation of Y, then it will be 0. So if X and Y are independent, then it's independent, right? We can't say correlation is 0, then X and Y are independent. Are you getting?
Yes, sir.
Okay. As I
Sir,
took the example of that one, correlation was 0, but there was a relationship between Y and X, right?
You took that example.
Yeah. Okay. So just think about this. Okay. So Jyoti Lakshmi has raised hand.
Sir, I'm Jyoti Lakshmi.
Yeah. Yes,
Sir,
please.
I have a doubt in some particular question. I read the question, sir. If the sum of 7 observation is 28
Yeah. One
and
second. One second. One second. Let me. Sum of 7 observations.
yes, sir. If the
Is
sum of 7 observation is 28
okay.
and sum of their squares is 140,
Sum of these squares is 140. Okay.
then calculate the population variance.
Means sigma square, right?
Yes, sir.
These things we need to compute. Okay. So I have given these things. I have given these things. But in the population variance formula, I have this summation of xi minus x bar. Okay. That means we need to find out this equation and this equation, kind of something.
Yes, sir.
I can extend this formula. Xi square minus x bar square plus 2 times of xi minus x bar. Simple expansion of a minus b raised to the whole square. I
Yes,
can
sir.
expand. Correct? Now,
Yes, sir.
let's this summation inside the bracket. So it will be summation of xi square minus summation of I is equal to 1 to 7 x bar square
Yes, sir.
plus 2 times of x bar is a constant, so I can take outside of the summation,
Yes, sir.
not this square. Now it is clear how I have expanded this thing. Let's make it n in general so far. So X bar is what? 1 upon n summation of xi,
Yes, sir.
correct? I
Yes,
can
sir.
write n times of x bar equal to summation of xi or not? See, can I write or not?
Yes, sir. Yes, sir.
Now, come to this 1 upon n summation of xi square minus c. What will be the value of this thing? Summation of x square is x bar square.
N of x bar.
N of x bar square. Why? X bar is a constant thing, right?
Yes, sir.
Plus 2 times of x bar. So summation of xi, can I write n times of x bar?
Yes, sir.
Correct? Now,
Yes, sir.
so 1 upon n summation of xi square minus n times of x bar square plus 2n times of x bar square. Okay. So can I write 1 upon n summation of xi square minus n times of x bar square or not? Correct?
Yes, sir. Yes, sir.
So you can note down this formula. This is nothing but the expansion of this formula. You can similarly write down the for the sample variance formula. Okay.
Okay, sir.
You can note down this formula. Now I will solve your question now.
Okay, sir.
So in the question, we are given this thing. Summation xi equal to 28, right?
Yes,
Summation
sir.
I is equal to 1 to 7, xi is 28. That means I have my value of n is 7.
Yes, sir.
I can find out the x bar.
Yes, sir.
What is this? 1 upon n summation of xi.
Yes.
So 1 upon n into 28 is what? 4.
Equal to 4.
X bar is 4. I have computed x bar 4. Now in the question, this things is given to me. Summation of xi square is given to me as 140. This thing is given to me. Sorry, this thing, right? So what will be the sigma square? 1 upon 7, 140 minus n times of x bar square. So n is 7 into x bar is 4. So it will be 1 upon 7, 140 minus 16 into 7. So it will be 1112, 140 minus 1112. So it will be 28 by 7. So sigma square is 4. Is that the answer? Hello?
I didn't get this question actually.
This I don't know from where it is she has asked. So in the question, some of the observations, 7 observation is given to us, and some of squares of the observation is given to us as 140. It was asking about sigma square, okay? Population variance. So
Okay.
population variance according to the given things, we are not able to apply this formula because it is given to us summation xi square something. So as we can expand the formula sigma square as 1 upon n summation xi square minus nx bar square. Okay, we can use the
Okay.
expansion formula. So from here summation of xi square is given to me. I can find in the question, and x bar I can find because summation of xi is given to me. X bar is nothing but 28 divided by 7, right? X bar is what? Summation of observation divided by number of observation. So
Right.
that's
Right.
the simple things I have done. Okay. So this formula you can remove things. Okay. Is it clear, Vansika? I think who has asked this
Yes,
question?
sir. Yes, sir.
Yeah. Okay. So tell you, Jyoti Lakshmi, what is your doubt?
Am I audible?
Yeah, you are audible.
I am having a doubt from quiz 1 in question number 84 and 80.
And I don't remember the exact 84 and 80. What is the question? Okay, so had you attended the quiz one discussion session?
No, sir.
After the quiz, one this session was happened there. We had discussed. I mean, Ishan sir had
Yes, I
discussed.
attended, but I couldn't ask.
The answers are there, sir.
Okay, okay. Can you tell me what is the question? I mean, I don't remember the exact question, but yeah, tell
No,
me the
sir.
question.
Key for key quiz one. It's there, sir. Answers are there. They can go out.
But sir, the key doesn't match with my answer and that answer, so I need an explanation.
Okay, okay. Just tell me what is your doubt.
The question is, figure 2 represents the distribution of runs scored by Suresh in a match of a cricket
Oh,
tournament. A bar
okay.
graph is given.
Uh-huh. Bar is there or histogram is there?
Histogram.
Okay.
So in class intervals
Okay, okay.
0 to 10,
Okay, 1 second. 0 to 10. 0 to
10.
10 means a class interval is given to me. That means I can find the midpoint.
Yes,
Okay. 0 to 10. Okay. For 0 to 10, what is the value?
0 to 10, 1.
1. Okay.
10 to 24,
10 to 24. Okay.
30 to 42,
30 to 40 is 2. Okay.
20 to 30 is 3.
20 to 30. 1 second. After 10 to 20, it should be 20 to 30, right? So 20 to 30 is what?
20 to 30 is 3.
3. Okay.
30 to 40 is 2.
Okay.
40 to 50 is again 2.
Okay.
50 to 60 is 1.
50 to 60 is 1. Okay.
And 60 to 70 is again 1.
Okay. So for this class interval formula, we have to find the average, right? As I can remember.
Yes, yes.
So for this situation, we need to find the midpoint of the class interval.
Yes.
What will be the midpoint for the first class interval? It will be 0 plus 10 by 2.
It's 5.
5. For the
5.
second, 15.
15.
25. 35. 45.
Yes.
55 and 65. Correct? What is the
Yes.
formula to computing the mean?
Sigma
Multiply
Fi
the frequency.
Xi by
Summation of Fi into Xi means 5
by.
into 1, right?
Yes, sir.
And we need to add all the observations. I mean summation of Fi Xi. That means these things, correct?
Yes, sir.
Divide by summation of Fi. That means these things, correct?
Yes, sir. Yes, sir.
No, 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 no. 1 second, 1 second. I think not this. So summation of Fi will be these things because frequency is given to us. For the 0 to 10, it's 1, 10 to 20, it's 4, 20 to 30, it's 3, correct? So what will the mean? Mean is sum of observations divided by the total number of observations. 30 was the correct answer.
Yes, sir. It's given.
Yeah. I think you might have done some calculation mistake, so you can recheck.
No, I divided by the number of matches. I didn't see the number of frequencies.
No, no, that's why see, there is two formula of mean. X bar is 1 upon n summation of xi, okay? When frequency is given to me, that means X bar is summation of Fi into Xi divided by summation of. Okay?
Okay, sir.
Clear? Yeah.
Thank you, sir.
Thank you. So, Asrita has raised hand. Yes, Asrita, what is your doubt?
Yes, sir. I have few doubts from previous qualifier test, sir. So
Okay.
I'll read out the question, sir.
I think you guys had not attended that session, na?
No, sir, not the October 16th exam. The before months
Okay,
qualifier.
okay, just, I
The
mean, I don't
Jan.
have the question right now, but yeah, you can tell me, I will try this.
Yeah, I'll read out, sir. No problem.
Okay, okay, just tell me.
Yeah, sir. In this, if there are two variables, x and y, each
Okay.
having n data points,
One minute.
where
Each having?
n data points,
Okay.
where each data point is obtained by xi is equals to I,
Okay.
and yi is equals to n plus I.
Okay.
What is the correlation coefficient of x and y?
Correlation coefficient of x and
Y.
what is the answer?
Answer they gave it as 1, sir, but
Okay.
I didn't understand the question only, so.
So question is xi have I, right? Suppose n
Yes.
data points. I means okay, n data points means x1 means 1, x2
Yes,
means
sir.
2,
2,
x3 means 3, x4 means
3.
4, x5 means 5, so on n. Correct?
Yes, sir.
What is yi?
Hmm.
N plus 1, n plus
Yes.
2, n plus 3, n plus 4, n plus 5, and so on. N plus n means it will be 2n. Correct?
Yes, sir.
Now, so let's assume, I mean, it is asking about correlation of x comma y. Okay. So
Yes, sir.
correlation formula is what? Summation of xi minus x bar into yi minus y bar
Yes, sir.
divided by
Divided by
square
standard
root of
deviation x and
xi
y
minus x bar whole square
whole
square root of
square.
summation yi minus y bar square. This is the final formula. Correct?
Yes, sir.
Now,
Yes, sir.
so this is the okay. Okay. So correlation between x and y. So that means I can say correlation between x comma n plus x.
Yes, sir.
I can say
Yes, sir.